In this video, I'm going to show you how to configure the ArtNet 2.0 driver to control some DMX fittings in a little cinema room example. We've got an integration designer file here already set up. It's got an XP8S as our processor, and we've got a little cinema room set up. We're using an iPad for control, and it's got some generic pages. In the driver bundle, you'll find this PDF document. Just make sure it's the right one for the version ArtNet Driver 2.0. In it, it gives a brief overview of the ArtNet and the DMX configuration. It then gives an example of a cinema room. And in this example, just to keep it simple, we're using a KX4 as our controller. In our example file, we're going to use the XP8S. We've got a network switch, and that's powering the controller via PoE. We've then got an ArtNet node, and this is all you need to be able to control some DMX lighting. The ArtNet node is also powered by PoE. We've got a couple of RGB fittings here, which are going to point at the screen. Now they're going to just add a bit of a colour wash to the screen when the movie's not showing, and then they'll go off when it is. We then have a controller that's driving 4 downlights, and this is our general lighting in the room, and they will dim down to kind of 10% when the cinema is being used. We've then got some additional fittings. We've got some little step lights which we've bought as a kit. Now that's not dimmable because the power supply is part of the kit, so we're just going to control that with a DMX controlled relay. The DMX controlled relay will have no dimming, it will just be on or off, and we'll set that up in the driver. We've then got an LTEC dimmer, which is a 4 output with 4 channels on each output. The first output, we're just using 2 channels, and this is to control some warm white, cool white or CCT tape. The second output we're using for some RGBW tape, so we've got a red, green, blue and white connection. The only hardware we need to control our DMX lighting system is the ArtNet node, and we've gone for a Chauvet AN2 DMX. It's available in the UK for £117, in the US you're looking about $200. If we have a closer look at the unit, you'll see that there are 2 DMX ports, port A and a port B. And if we set this up correctly, this will give us 2 duplicate outputs. So we can in effect have 2 outputs that we can send to 2 different locations without using a DMX splitter. If we have a quick look at the other side of the unit, you'll see that it's got an RJ45 connection, and this is PoE. You have the option as well to provide it with a 9-volt DC power supply, but PoE works fine. If we go back to the PDF documentation and we scroll down, you'll see there's instructions for setting up the Chauvet DMX AN2 ArtNet node. Now I have one set up on my network, so we'll have a quick look at it and set it up. You can configure it to either be DHCP or a manual IP address. I'd recommend going with a manual IP address every time. You've then got the 2 output ports that we saw in the photographs. So we've got port A and we've got port B. They both need to be set to output, and they both need to be set to ArtNet. And they both need to be set to the same universe. We're going to use universe number 1. By setting these 2 the same, it gives us duplicated outputs on our A and B. If we go back to the PDF document and we scroll down, we'll see that there's a warning about CPU usage. To keep CPU usage to a minimum, we need to try and keep all our DMX channels as low as possible. Now to do this, it's an idea to make up a spreadsheet or a little table of the DMX addresses and then put all our fittings into that table. So first we're going to put our downlights onto address number 1. It's a single channel, so it's just going to take up address number 1. Secondly, we're going to put our RGB power cans on address number 2. Now 2 is the base address, so that's the red channel, 3 is the green channel and 4 is the blue channel. On channel 5 we're going to put our step lights, which is our DMX controlled relay, and again this just takes up 1 channel, channel 5. Next we're going to have the LTEC driver, and obviously this has 2 outputs with 4 channels on each output. The first output we're just going to use 2 channels, one for the warm white and one for the cool white. The second output is going to be for our RGBW tape. The first channel, which will be on base address 10, is for the red, and then followed by the green and the blue. Now we need to go back to Integration Designer and we need to add the fittings from our table. So we'll click on the Add Workspace item, and under Drivers in our User section we need to find the ArtNet driver. So we'll just simply search for ArtNet and our driver will pop up. Now the driver is a multi-instance driver, so every fitting is its own device. So we'll select fitting number 1 and we'll select next. It's a good idea to name these as we go along. This first fitting we'll have as the downlights, which was our single channel dimmable white fitting. So we will add that and then we will go to the configuration for that fitting. So we will click on our source properties and we will change the fitting name to something more descriptive. We're going to call it downlights. These names will be used in a list later that the user can select from. We then have 5 options to choose from as to what type of fitting we're going to use, and it's important that we get this right. The first is single channel dimmable white, and this uses 1 DMX channel. The second is RGB, which uses 3 DMX channels. We then have RGBW, red, green, blue, white, that uses 4 channels. We then have our switched single channel DMX, which is non-dimmable. We then have our warm white, cool white, where we can set color temperatures of CCT tape. So we're going to select single channel dimmable white, and from our table we'd already decided it was going to be on address 1. Now our first fitting is added, we'll have a look at the global properties for the driver. So in the driver properties we've got space for a license key. The driver will run for 2 hours for testing and evaluation. There's then the room fade time. This is set by default to 2 seconds. You can change this and it will be stored with the presets. There's then a setting for the IP address, and it comes by default set to 255. This is a broadcast. Now we could set it to the IP address of our ArtNet node, which was on 120, and the driver will communicate directly with the ArtNet node. But on 255, the packets are broadcast, so anything on the network will receive the ArtNet packets, and this is useful for testing and commissioning later. The next option is to set the ArtNet universe, and we're setting it to 1. This is because we've set up Universe 1 on both our outputs A and B, so we just need to make sure that they're all set the same. You can change this if you need to. I've added our additional devices for all our other fittings in the table, but you'll notice on CCT Cove, which is a warm white, cool white, that there are a couple of extra variables that we need to enter, and these are the warm white and cool white values. You'll find these on the manufacturer's information. It depends what type of warm white, cool white tape you're using. I've gone with 1800 to 7000, which is a typical value. These values are used later to give an approximation of the actual Kelvin output of the tape. Now would be a good time just to check that we've got everything correct from our table. So we've got our IP addresses, we've got our fittings listed. So we've got our downlights, a single channel dimmable on DMX channel 1. We've got our RGBW pelmet on 10. We've got our CCT Cove, which is the warm white, cool white, and we've got our colour temperatures entered, and that's on DMX 6. We've got our power cans on 2, and we've got our single channel switched steps on 5. Although we have a generic lighting page already set up in Integration Designer, I'm not going to use this. I want to put all my lighting onto one page, and I'm going to use the inbuilt layer switch and list facility within the driver to just display the controls that the user needs when they select an individual fitting. So I'm going to get rid of the viewport and I'm going to get rid of these other controls, and then I'm going to start to build my user interface. So the first thing I'm going to do on my lighting control page is to add a list. Now this list acts as a layer switch, so that if the user selects a fitting from the list, it will only display the controls that they need for that fitting. If you tag the list as fitting list, it will auto program. There's a text variable called selected channel name that you can use to give feedback to the user if your list doesn't do highlighting like on an iPad. We now need to add a room master lighting level controller, and this controls all the lights that are connected to our ArtNet system. So that's everything basically. So if this is set to 0, there will be no light output. Everything's tagged, so you don't need to do any programming. Master level is the name of the slider, and it will auto program. There's also a feedback variable called master level that will give you a percentage value. We then have 4 function buttons. We have master level up is the tag, and that increases the level by 10%. We then have master level down, which decrements by 10%. Master level on turns the level to 100%, and master level off sets it to 0. We now need to create a layer for each of our fittings so that the user is only shown the controls for the fitting that they've selected. So we'll create a new layer and we'll call it downlights because it will show our downlight controls. We'll make sure the source is set to downlights, and in the visibility option we'll use the inbuilt layer switch so that if downlights is selected, then this page will be displayed, or this layer will be displayed. We need to do this for the other fittings as well, but we'll just drag this one down to downlights and we'll paste in some controls for our dimmable downlights. In the controls we've got a slider called light level, and again it will auto program with light level. We've also then got a text feedback called light level that will give the fittings percentage level. We've got light level up, we've got light level down, these do 10% increase and decrease. We've got light level on that will set it to 100%, and light level off that will turn it completely off. There's also a text variable that you can use called fitting name. This will show you the fitting name from the configuration. I've now set up layers for all the other fittings. So we've got our CCT cove, our RGBW power cans, our steps, and each of these is then configured so that it's pointing to the correct source, and it's only displayed when the layer switch from the list is selected. Now, because everything is tagged, all we need to do if we want to duplicate these controls, which are the same across pretty much everything, is we can just copy and paste to the other layers and they will auto program. So we can then paste that into for our CCT fittings and it's the same, and we can do the same for our screen power cans and they'll all auto program. For our steps we're going to have to add a different control, so I'm just going to paste some slightly different ones here. We've still got the on and off level, which is light level on and light level off, but we have a new feature called toggle. Now this only works for switched fittings. If it's on, it turns it off, and if it's off, it turns it on. For our fittings that need colour control, like our RGBW pelmet, we need to add some colour controls. So we'll just paste these in. Everything's tagged, so it should be very simple to program. We've basically got three sliders. The first one is light red level, and that auto programs. Then we've got green level and blue level, and we've got feedback to match as percentages. We've then got these colour selections, so we've got white, we've got red, and we've got orange. All these are tagged and they're all in the documentation. For our RGB power cans, we can use exactly the same controls. We just paste them into the page, and because everything's tagged, if we auto program, it will all auto program itself. Simple as that. For our CCT or warm white, cool white fittings, we also need to add some controls, so we'll just paste some in. We've got a slider, and the slider is tagged as Kelvin. This fader fades between the warm white and cool white channels. There's also a text variable that gives you an approximation of the current Kelvin temperature of the warm white, cool white tape. This is called Kelvin text. There are then 8 preset buttons that give you a range of temperatures between the warm white and the cool white. These are all named and tagged in the documentation. So we'll do an upload, and while we're doing the upload we'll just have a look at some software that's really useful for helping with diagnostics. It's called DMX Workshop. Now this software from Singularity helps you find your ArtNet nodes. It can find our nodes on the network, it tells you the IP address, it tells you lots of details about it, and it tells you that it's on Universe 1 for both outputs. But the really useful thing is that we can click on this receive and we can use this as an ArtNet monitor. Because we set the address to 255, any packets will be received by this software, and we can see that the little packets counter is going up, and that means we've got ArtNet being output onto the network from our controller. Now that our upload's complete, we'll have a quick look at the iPad and make sure that our interface is working correctly. If we click on the lighting page, we can see that we've got our layer for the downlights. We've then got our layer for our pelmet with its colour controls, we've got our CCT controls, we've got our screen power, and we've got our steps. So let's use the data monitor to see if our controls actually output ArtNet. So if we put up the room master, you'll see that the output is still at 0. Until we turn on the actual downlight itself, and then the output goes to 255 or the maximum. We can change the output to percentages in the data monitor. It's important to understand how the room master and the fitting dimmers work together to affect the output. If we pull the master down to about 50%, you'll see that the output goes to about 50%. If we then pull the fitting dimmer down to about 50%, you'll see the output would go to about 25%, because half of a half is 25%. As we increase the master, obviously the output increases in proportion. If we look at our RGBW pelmet, we'll see that when we turn the fitting dimmer up, we still get no output. That's until we slide up one of the colours. So the red value has now gone up, and the green value also goes up. Now when we slide the blue value up, you'll notice something strange happens. The blue value doesn't go up, but the white does. This is because the driver calculates the white value from the levels of the red, green and blue. So one channel will always be at 0. As we select from any of the colour presets, you can see that the output changes accordingly. The change in output is using the fade time that's been set in the configuration, but you can change this at any point. For our CCT cove, you can see that when we turn the fitting dimmer up, the warm channel goes to 100%, or it would do if we just put the master up to 100%. But you'll notice how the master changed the levels of all the other fittings. Now we have the Kelvin slider. Now this basically is a crossfade between the warm white and the cool white fittings. So as we slide it up to the cool end, you'll see that our warm white tape has gone to 0 and our cool white has gone to 100%. As we adjust the Kelvin slider, you'll see that there's a feedback value that's calculated using the warm white and cool white temperatures you entered in the configuration. For our step fittings, which are non-dimmable, just switched, you'll see that the output switches between 0 and 100% instantly as we turn them on and off. We can also use the toggle button to turn this on and off. Because it's not dimmable, as you pull down the master slider, you'll see that the value stays at 100% until the master slider is completely off, and then comes back on immediately to 100% as soon as the master slider is turned up. So we've tested our system and we're definitely outputting ArtNet and everything seems to be okay. But what if it isn't? Let's go back to our configuration. Now if we had a conflict of DMX addresses, this would cause an issue. Now we've entered everything from our table, so hopefully we've got it all correct. Now we're going to create a deliberate error. We're going to change the RGBW pelmet from address 10 to address 1. Now we know we've already got the downlights on address 1, so this will throw an error. Now we can check for this error by adding a test button to our iPad. And if we tag this DMX test, it will add this function. The function runs a test that checks for DMX conflicts and outputs to the XP log. So if we do a quick upload and we browse to our processor and we go to the system log and we press the test button on the iPad, we'll see that it spits out some information onto the log. It says it's performing the test and it's found some conflicts. It's found that conflict on address 1, fitting number 2, RGBW pelmet red, is already being used by the downlights. Now we knew this already, and we also know that there are some other conflicts there too. So if we change this back to channel 10 and we upload again, and then we refresh our page, we go to our system log and we press the button again, it says it's performing the conflict and it's found no DMX conflicts. So it's worth doing this if you have any issues. Now we've got all our ArtNets and DMX working correctly, we can add some scenes. So we'll just paste in some scene buttons and we'll drag those down to the bottom. The driver can store 8 scenes and they're recalled with the tags scene 1, scene 2, scene 3 and scene 4, obviously up to scene 8. They're stored using scene 1 store, scene 2 store, scene 3 store and scene 4 store, again up to 8. We'll go back to our data monitor and we'll set up a couple of scenes on the iPad. So we'll turn our master level up full and we'll set our downlights to a value. We'll then go to our pelmet, we'll turn the level fitting up and we'll pick a colour and we'll save that to scene 1. We'll then adjust the colour and we'll save it to scene 2. We'll go back to our downlights and we'll just adjust the level slightly on that as well. Now that we've got our scenes stored, we can just press the scene 1 and scene 2 buttons and you'll see that the outputs are recalled. If we go to our colours, you can see that the colours change as well. Scenes use the fade time that was set when the scene was stored. In summary, this driver allows you to control 30 DMX fittings of 5 different types with 8 scenes using economical standard ArtNet protocol hardware. Thanks for watching and please don't hesitate to contact me if you need more information.